Hello, this is Nathan Hayes, and today I'll be talking about my the coding problem set 2, the credit cards. For this first problem, it was paying off debt in the year, and it had a minimum monthly payment required. I remember for this problem, I wanted to do a I wanted to do a loop. I remember that, but I didn't know how to call upon previous I guess like terms for it. So there was a lot of things that I had to learn for um this specific problem. For this problem I learned that you can do for loops like this. You can do it like 1 comma 13, and I should get 469.11 again. Yeah, so it's the same as doing the loop. And I didn't know that you could create definitions. At least that's what I'm assuming this is a definition of like, this is what New Balance is. And I remember doing something kind of like this in Java when it came to I forget what it was called, but it was kind of like calling back to a previous thing. And you have like input variables, and with those variables, um it'll return like a formula, or it'll return a variable, but I didn't know you could also do like returning a formula when you call upon New Balance, and you have like what it says here. You have, I'm putting in unpaid balance and the monthly interest rate, and it's giving me back this, and it's iterating through this 12 times. Um, yeah, so I had to learn that. I also learned that there's no difference between using these and I guess like what would that be, like an apostrophe instead of like quotation marks. Like apparently they're the same, and you can turn integers into strings, and you can also round them, and you get to choose a decimal place. So essentially what's happening here is it's iterating. I is supposed to be like month, and it's iterating through the months, and we're saying the minimum payment is equal to the minimum monthly payment, the formula that we have for the minimum monthly payment, which consists of the balance and a minimum rate. And the return formula is balance times that minimum rate. And our minimum rate, like that we're inserting into this formula, is the monthly payment rate, which is 0.02. So it doesn't even have to be the same kind of a variable name. It's just whatever you're putting in there, that's the formula they're getting back. But it uses this value for this variable. It doesn't use whatever this is. So we're iterating through this. Then we're seeing what the unpaid balance is. And we're saying that the monthly unpaid balance is a formula of the balance and the minimum payment. We go here, we see that it just returns the balance subtracting the minimum payment that you had to make. Then we're creating a new balance. We're saying balance is equal to new balance, unpaid balance, monthly interest rate. We go here and we see that it is unpaid balance plus the product of the interest rate and the unpaid balance. So it's just like adding on interest to what you have, and then we see that we get 4,691.11. For the next problem, there was no interest rate. Yeah, it was a fixed monthly payment. Trying to find the lowest payment that you can make. I did these a while ago, so I'm trying to remember exactly what I did. Oh, I remember. Yeah, okay. So it wanted this in like increments of $10 bills, so kind of like an even number. We still have a balance, we have an annual interest, and we have a monthly interest rate, but there is no minimum amount that you have to pay. We're just trying to see how much it would cost to pay all of it off in the year, like the entire balance. Something that I had to learn in this was that you can create infinite loops with this while true, which I didn't know you could do. Um, I can't recall doing something like that in Java without doing recursion. So I suppose this is kind of similar to recursion in that way. Yeah, I guess it would be kind of similar to recursion, right? But we're saying that we're creating a new variable, new balance, which is equal to balance. You do this because you're trying to. This is going to be something that you change a lot. New balance is like, I mean, it changes a couple times, right? Like 12 times apparently. Um, so for month or any variable in range 12, new balance is equal to new balance minus the payment. So essentially what this is saying is like, for every month, we're taking away the payment from our balance, which is 5,000 on this new balance. And then we're adding um, the interest rate on the balance that we have onto our new balance after taking away the payment. And then we're going to say that, well, if new balance is greater than 0 for that month that we iterated through, increase the payment by 10. So then it'd be 20 the next go around. And then we're going to say new balance is equal to balance. Else, if new balance is not greater than 0, it's equal to 0, or it's less than or equal to, then we're going to print lowest payment equals the string that we were talking about earlier, payment, which is, the lowest number that you can use, or that you could pay to pay off the entire, I guess it's like debt, kind of, yeah. This problem, I remember required me, because I did this very recently, required me to look at this. Binary search, apparently this is something that I've done in calculus, and it's something that I've done in Java as well. I had to look up a YouTube video of this guy who was saying essentially binary search is kind of the same as like, or it deals with like big O notation. And I remember doing that in my recent Java classes. So my I, I think my code is correct because I did it based off the information here, like creating a lower bound and an upper bound. They have to be different signs. And, like we're seeing here, it says that if the sign of one, or if the sign of your midpoint, or I think what the professor had in his video was, it was called payment or something like that. But if that is equal to A, then I think it's like A equals C, else B equals C. Well, I'll just show you what that's essentially like. So it's literally just like, or it's like this up here, or it's this right here, this elif. If this bound, let me just start from the beginning. Um, my low bound and my upper bound are different than the one given here because I watched the video and the professor's was different. And so I don't know if he wanted us to use these values, or if he wanted us to use the ones that he had for lower bound and upper bound in his video. I'm not sure. I suppose we could try, right? Maybe we'll see. See what happens. is the lower bound? Lower bound is balance over 12. Oh, this one was equal to, it was like balance, the product of 1 plus monthly interest rate to the 12th power. That divided by 12. The whole thing divided by 12, divided by 4.0. I mean, I used the professor's way of debugging because when I was first doing this, I didn't realize that I didn't have a negative here. I wasn't exactly following this, but oh yeah. So F and A have to have opposite signs. Kind of like looking at this as like lower bound and upper bound. They have to have different signs. And then it's saying here, this, your like midpoint, which is that's what I have it as, pretty sure. Yeah, my midpoint is lower bound plus upper bound divided by 2, which is like my C. So yeah, so you find this C value and then you plug it back into the function and you'll get a number, a negative number. And it's because this midpoint is negative, you replace one of the bounds is replaced with A, and you're just trying to make the difference between your lower bound. I'm just gonna call this lower bound. The lower bound, which was 1 and 2, it's now 1.5 and 2. Right. So you're just swapping your low or your midpoint with your lower bound. We will try this. The number I got was 451.7. This was me trying to see if I could do to the power of. Anyways, 451.57. That's 451.61. So it would have been the same. I assume the reason why it would be the same is because my margins are like super thin. And the reason why they're super thin is because of this. So I think it said something to like cent. Yeah. Try running code. Oh, that's yeah. Give me dollar and cent amount. This goes to work. So yeah, I think this is just recursion. But yes, that is what I did here. I'll explain the code. I don't know why the professor would do it this way, like change the upper bound and lower bound, if it ultimately didn't matter. What was it, 451 point whatever? 451.61. Let me change this back. I'm pretty sure it was also like 451.61. 451.57. So it's like cents, but it's definitely interesting. For my iteration here, I had a counter, and I'm saying that while the count is less than or equal to 50, much like the professor's video, I wanted to have like iterations, but obviously I listened to what he said. If there's going to be more than 50, then perhaps you have done something incorrect. And then I just increment count. I create a local variable balance, new balance, which is equal to balance. I create a midpoint, which is these two divided by 2, the lower bound and the upper bound of 2. And we are not incrementing, but we are iterating through 12 months. So it's kind of the same thing as the second problem, right? Yeah, kind of like the second problem where you're taking away the midpoint from the balance that you have, 5,000, and you're adding interest onto that. This is the debugging information. And then here I'm saying that if the new balance is more than 0 and it's also less than or equal to 1, or if the difference between the upper bound and the lower bound is equal to 1. Sorry. Then that would be the lowest payment. And I just wanted to round that up to 2 decimals. I don't know if the professor did that, but like look at how big that number is. Like no one's paying 451.575 cents. No, they paid 57 cents. And if that's the case, you would just break. Else, if you create a new definition for the lower bound and the upper bound. Thank you so much.